compound interest with tables. Now we can use compound interest with tables to find interest compounded quickly and efficiently instead of using a formula. So when you use compound interest with tables, you're going to get something like this, where it's going to have a time period down the side. Might be like 1, 2, 3, 4, 5, 6, all the way down maybe to 24. And we're going to have an interest rate across here in terms of a percent. Might be like 1, 2, 3, 4, 5, 6, 8, 9, 10, and 15. And in here we're going to have a lot of values. We're going to have 1.010, 1.020, down here 1.270, all the way over here in 15 and 24 matchup, we're going to have 3.059. All right, but what do all these mean? Well, remember, this is compound interest, and there is a formula for compound interest that's future value equals present value times 1 plus our rate to the power of n. Let's have a look at if let's just add in 8 down here. Let's have a look at one of these values. So 8, where 8 and 15 match up. So this one here is where 8 and 15 match up. And it's 3.059. But why is it 3.059? So let's just look at this part of the formula, the 1 plus r to the n. Because this is all we have here in this table. We have a bunch of n's down the side, they're our time periods, and we have a bunch of r's, our interest rate across here. Let's put those values into the formula, just in that section. So remember, our percent's got to be over 100, and our time period, sorry, our percent is actually 15, not 8, that's the time period. So that's 15, and our time period's 8. And putting that into the calculator, you're going to get 3.059022863. And if you can see, that is the value that was in the table lining up with 8 and 15. So the values in the table is just the 1 plus r to the n part of the formula, which is going to make things really, really easy for us, because if we know the present value, all we have to do is times it by one of the values in the table, which represents this part of the equation. And let's have a look at an example. So what is the future value of $1,200 at 15% per annum over 8 years? Now, we just looked at that value in the table, and the value in the table we needed was 3.059. And using our future value formula, we know future value equals present value, 1 plus r to the n, and the 3.059 was just this part here. So we can easily find our future value by taking our present value and timesing it by the value in the table. And if we do that, we get $3,670.80. Okay, let's have a look at another question. All right, you want to save $5,000 in 2 years' time. And you can invest at 12% per annum, compounded monthly. And what do you need to invest now to do that? What do you need to invest now to do that? So the important bit in this question is the compounded monthly part, which means that everything needs to be in terms of months. Okay, so we're talking about 2 years and 12% per annum, which means 12% per year, but everything needs to be in months. So to convert our years to months, we need to do a few things. So 2 years, well, we can times that by 12 to convert it to months, which is going to give us 24 months. And to convert a rate from years to months, we need to divide it by 12. And that's going to give us 1% per month, which makes sense because if it's 12% per year, it's going to be 1% for every month in that year. And now we can just look up the value in the table that matches with the 1% and the 24-month time period. And that value in the table is actually 1.270. And we know future value is going to equal the present value times the value from the table. So if I want to save $5,000 in 2 years' time, this is talking about a future value. So 5,000 is my future value. My present value is what I want to find out because I want to know how much do I need to invest now in the present times my value in the table, which is 1.270. And to solve for present value, I can just divide both sides by 1.270, which makes them cancel out. And I have our present value equaling $3,937.01. And if I do that in 2 years' time, I'll have $5,000 in total.